Hello everyone, welcome to the course of Digital Logic Design. In today's class, we are going to learn a topic called binary number representation. So let's see how this binary number representation has been classified. So coming to the flowchart of it, the binary number representation has been classified into unsigned representation and signed representation. Okay. So what is unsigned representation? The unsigned numbers don't have any sign for the representing negative numbers. So the unsigned numbers are always positive numbers. So unsigned numbers will be always positive numbers. They don't see any kind of sign before the number like 1, 2, 3, etc. Okay. So these are positive numbers which we are considering it as unsigned representation. Coming to the signed representation, this signed representation numbers have a sign bit so that it can differentiate positive and negative integer numbers. Like, let's see the negative numbers. So in order to mention the negative numbers, you need to mention negative like 1, -2, -3, and so on. Okay. So this is how the signed representation with respect to integers are considered. Same way in the binary data also. So binary data also will be having numbers zeros and ones, right? So for this binary number representation also, we can indicate what that particular binary number is of, whether it is a positive number or negative number. Okay. So how that is represented in sign magnitude form. So for the sign representation, it is again classified into sign magnitude form, ones complement form, and twos complement form. Okay. So in the coming class, we are going to see how the negative numbers or positive numbers are represented with respect to ones complement and twos complement form, as we have already learned how to do or perform the operation of ones complement and twos complement, right? Now let's see what is the sign magnitude form. Okay. So coming to sign magnitude, okay. So if the sign bit is 0, if sign bit is 0, okay, if the sign bit is 0, then the number is positive. Number is said to be positive. And if sign bit is 1, then the number is said to be negative. Okay. So how this generally binary represented is in sign bit, okay, followed by magnitude form. Okay. Let's see one example how the sign bit and magnitude form is represented. For example, consider 3-bit binary data. Okay. So we are considering a 3-bit binary data. So the number one, one, 1. Okay. So generally the 1, 1, 1 indicates magnitude or original data. Okay. So this is the original or the magnitude data. So 1, 1, 1 indicates number 7 with respect to binary. Now, how we can say whether this particular 7 is a positive number or negative number based on the sign bit attached before that particular number. Okay. So if the number is 0 in the sign bit position, okay, the value what we have is plus 7. Okay. Suppose if you take the 3-bit data, 1, 1, 1, which is magnitude form. That means 111 is 7, right? And the sign bit, let us say what we have before this magnitude form is 1. This is the sign bit. So as the sign bit is 1, it is indicated as negative. Okay. So 0 indicates positive. 1 in the sign bit indicates negative. Okay. So this is how the sign magnitude form is applied to whether a positive number or a negative number. Okay.